All right, so today's class is about variables, expressions, and equations. Okay, we're going to see what these are and also learn how to evaluate and check some equations for solutions. So let's first start with what an expression is. So throughout this class, we're going to be talking about, this is an algebra class, so we need to understand algebraic expressions. All right, so an algebraic expression is basically an expression with letters and some numbers. Could be like this, or it could be something like this, 2x plus 3. That's an expression. The x is a variable. And these are just numbers or constants. You can also call them constants. Okay, so the reason why we call this a variable is because the value can change depending on what we give it or what's given to us. This could be 1, could be 2, could be 4, whatever value. And as a result, the whole expression here, the values, the whole thing can change. So this is a variable, the value changes. We'll see, for example, this 3 or whatever value you might give it. For the constant, they don't change. Constants are fixed. It's constant, that means it doesn't change, it's fixed, it's whatever it is. You might have one letter, or may have more than one letter, let's say 3x plus 4y minus 7, that's also an expression. Could have different powers, let's say x to the second minus 5x plus 1. Could be any letters, not only x and y, could be a, b, c, for example, a minus, for example, 3b plus 4c, and so on. So all these are expressions. Operations could be addition, subtraction, could be even division. For example, let's say 3x divide 4y plus 4. So this is what we mean by algebraic. Okay, algebraic expressions, because the expression is composed of, basically, we can write here, we could say combination. Combination of numbers and letters. Okay, so that's the quick definition of an algebraic expression, just a combination of number and letters. These we can also call variables and constants. That means the same thing. Now let's see how to evaluate. Let's see, why do we call this a variable? What makes it a variable? So let's say, so let's do some evaluations of evaluating algebraic expression. Let's take this very expression, very first one, plus 3. So this could take different values depending on the value of x. So let's say if x is, so if x is 4, so to evaluate this, means we take the value of x, we plug it into this, and we simplify. So plug x and simplify. So to do so we get 2. 2x means 2 times x, which we can write like this. 2 times whatever the value of x is. What is the x in this case?
4.
That's right, we have a 4 here. And the rest is a constant. This doesn't change. It will be constant or fixed the whole time. So we can write plus 3. Okay, once you do that, you simplify. So we plugged. Now we're going to simplify. Of course, we follow the order of operations. So which operations do we do first here?
Multiplication.
Exactly. So this is what we learned last time. We'll talk about the order of operations. This is one application of that order of operations that we learned last time. So that's 8 plus 3, and that's 11. So if x is 4, the value of this expression is 11. If x is some other value, this value will change. So this varies. The value of x can vary. That's why it's called a variable. It's not a constant. It's a variable because its value changes or varies. Let's see what happens now if it's a different value. This time maybe x, maybe 1. Same thing, I'm going to take the 1, plug it into the expression, so it would be 2 times x, which is 1 in this case, plus 3. And again, we use order of operations to simplify. So I got 2 here, plus 3, and that's 5. As you can see here, we got 11, we got 5, all depending on the x. That's the only thing that changes in the expression. Not the 3. 3 will always be there. It's a constant. If you have more than one variable, x and y, then both of them can change. You'll need 2 values to evaluate. So let's try to evaluate something like this, or that one specifically. So that's an example. So another example here. So 3x plus 4y. So in this case, to evaluate this, since we have 2 variables, x and y, we're going to need 2 values. So we need, for example, x2 and maybe y negative 1. All this will be given to you. You don't have to find these. So I'll give you the expression, give you the values. All you have to do is plug and simplify. Okay, so we're going to take both of these and we're going to plug them into this. Okay, so 3x, again, that means 3 multiply something, multiply x. So I suggest that you put some empty parentheses. The operation is a multiplication, just like here. And what goes inside the parentheses again?
2.
The 2, that's right. The x, will substitute the x for 2, plus 4. And again, for the y, just write some empty parentheses like that. Inside
Negative 1.
That's right. We already have negative 1. This is a constant, as you can see, does not change. It doesn't have a letter or a variable. It will be always that. Now we're going to use the order of operations. Okay, is simplify. Simplify using what we discussed last time, which is Pemdas, the order of operations. So what do you do first here to evaluate this expression?
Multiplication.
Exactly. So you have 2 multiplications here, one here, one here. Let's do those.
6.
That's right, 6.
Plus negative 4.
Negative minus 4, okay, and minus 7.
Wait,
Now
it wouldn't be plus negative 4. It would be minus. It would be 6 minus 4.
Plus negative 4 will turn into a negative. Or think of it as positive 4 multiply.
Positive 4 by that. Okay, and there's no.
Multiply negative 1. Then when we have these, we evaluate them left to right. Left to right. So we can do these two first, left, and then the right. So this is 2 minus 7. What's 2 take away 7?
Negative 5.
That's right, negative 5. We're going to have a whole class on signs in the future. Probably next class, or the following class, we have whole class discussing all the signs of all the operations. And that's basically the value of this expression when x is 2 and y is -1. So we can say when x is 2, y is -1. If these values change, then this will also change. The value of this will be different. The expression might be something like this. So let's try an example like that. So maybe 3x to the second minus 2x plus, for example, 1. And when x equals, for example, -1. There's only one variable here, so we only need one value. So both of these will be substituted by this value here. So we can say 3. So again, you just remove the x's. All these x's will be replaced with the value of x. So -1, but everything else becomes doesn't change. 2 stays there. Everything else the constant. Only thing that we replacing is the negative, the x with -1. Okay, so now once you plug, we're going to use Pemdas again. Okay, Pemdas. We always start from parentheses. So which operation do we do first here? Everybody? Which one? So this is all of operation. This is the expression. What exactly do we do first here?
Parentheses, so we would do the -2 multiplied, -1 multiplied by the 2 first.
So when we mean parentheses, we mean something inside of the parentheses. So here, we only have one number, So there's nothing to simplify inside the parentheses. So the next operation is, what does the E stand for? Everybody, what is the E for in the order of operations we discussed last time?
Exponents. Get rid of your exponents.
The exponent.
Exponent.
That's right, the exponent is here. So we're not doing the multiplication yet. We're not doing 3 times -1 yet. That's multiplication. So the exponent must be done first. -1 to the second is -1 times -1, which is
1.
1. Exactly. So this is 1. The whole thing, everything else stays the same. All right, we're done with the exponent. Now we're going to evaluate the multiplication. How many multiplications do we have here?
2.
2 of them. That's right. So we're going to do both. So 3 here. We have another one. -2 times -1 would be positive 2, and bring the 1 down. Good. So we're done with multiplication. There's no division. Additions and subtractions, we do left to right. So do this one first, and then the other one. Even if we have the subtraction here, we do left to right. So these are left to right. These two also are left to right. So do that first. 5 plus 1, that's 6. Okay, so that's how you evaluate an expression given a value. Plug it. This is an algebraic expression. Because it has variables and numbers, but once you plug the x, this turns into this expression, which is an arithmetic expression. Okay, arithmetic expression doesn't have letters, only has numbers and operations. So that's the difference between the two. X's, it's an algebraic, if not arithmetic expression. And when you get to the arithmetic expressions, we use the order of operations to simplify them. Okay, so we use order of operations to simplify the arithmetic expressions. Be careful with the signs, be careful with plugging the values. You want everything to be perfect. If you don't plug the value correctly here, you'll not get the answer right. You'll mess up you miss out the whole expression, and you change pretty much everything. All right, let's see. Does that make sense? Everybody, any questions about this?
Yeah.
Good.
No, it's pretty simple.
All right, so let's do another one. Now I'm going to do an expression with a fraction. So you may have something like this, and some other stuff down here at the bottom. Let's say we need we need this to be an expression, so we need an x somewhere before we simplify it. And also maybe 3 times okay, so we have an algebraic expression in form of a fraction, which is just like the other ones. Whatever we can do with these, we can also do with that. Pretty simple. So let's evaluate this. When x, for example, is maybe 1 or 2, okay? When x is 2. So we're going to take the x again. We're going to plug it all over the place here. Well, wherever there's an x, we substitute that with its value, the given value. Then once we do that, it turns into an arithmetic expression, which we can simplify using the order of operations as we did it here earlier. All right, so it's 5 plus 2. We're going to change this to 2 minus 4 to the second power. And over here, same thing. So I have 3 multiply x. But instead of x, we need 2. To the second power, so 2 to the second power, and minus 1. Okay, so we plug. All right, now we're gonna basically just simplify this. All right, so when it comes to simplifying order of operations with fractions, we do Pemdas pretty much for both. So this one has its own order. Then we go to the bottom and pretty much start a new order for this one. We can do them at the same time, but independently. Each one has its own order. So let's start with the top here. What do we do first?
Get rid of the exponents.
If you look at Pemdas, so what exactly is done first?
Parentheses first.
Exactly, the parentheses. So the inside of the parentheses. So this will be 5 plus 2. Then we have 2 take away 4, which is
-2.
-2, that's right. And we have the power, which stays there. Okay, go to the bottom and start a new order. What do we do first here?
Exponents.
That's right, so we have 2 to the second. So we have 3 times 4. 2 to the second is 4. So again, we are not doing the multiplication first. The exponent has priority. Back to the top. What do we do now after the parentheses?
Exponents.
Exponents, right? Again, Be careful here. A lot of people make this mistake. It's not 2 times -2 yet. Evaluate the exponent. These will change. Will not change now. And addition is the last thing you want to do. As you can see here, addition and subtraction are done last. So do not be tempted by doing this first. It will be wrong. So it's going to be 5 plus 2. -2 to the second is -2 times -2, which is positive. All right, back down here, multiplication, subtraction, of course. Multiplication first, minus. Go back up here, addition, multiplication. Multiplication is here, addition is here, so we're going to do the multiplications first. So 5 plus 8 over 11. And last step, we got 13 over 11, which is a fraction. What type of fraction is this?
Improper.
Improper. Can we simplify it?
No.
We can't. Nothing goes into 13 and 11. Both are prime numbers. But we can write it as what kind of number? We can write this improper fraction in the form of some sort of number. What do we call that number?
1 whole
Okay,
and over 2/11.
exactly. What do we call this type of number?
Proper fraction.
This one is proper, and we turn it into?
Improper.
No, this is a mixed.
Mixed number. I mean mixed fraction.
That's right, mixed number. This is improper. We turn it into mixed number. And that's your final answer. Okay, so when you see evaluate, that's the key word here. Is a question like this. It just means plug the value into the expression, use the order of operations to simplify it. So that's what we mean by evaluating algebraic expressions. Okay, so we know what a variable is. It's just a letter that changes in value. An expression is something like this with numbers and letters. Now, let's look at equations. What is the most remarkable thing about an equation? Or what does it contain that makes it an equation? How do you know if a statement is an equation? It's in its name. Equations have some sort of symbol, right? What symbol is it?
A variable.
It's a variable, but what exactly makes it an equation? So is this one an equation, for example?
You gotta have equal to each other.
Exactly, you gotta have an equal sign. So if you have, for example, x plus 4, that's an expression. And this is an expression. To make it an equation, just add an equal sign to it. And some other statement on the other side, for example, 7. So there will be questions in the homework asking you, is this an equation or an expression? It's very simple. Expressions do not have an equal sign, just numbers and letters. But an equation, of course, as the name implies, equations have equal signs. Equations or equalities, you must have an equal sign. And of course, each equation has a letter in it, a letter or the unknown that we usually try to find. This is usually unknown, and we try to find it. For today, we're not going to learn we're not going to solve equations. We're going to do that in the future in a couple of classes just for solving equations. Today, we're just going to check whether a couple of numbers are solutions. Check whether x, for example, 3, and x, let's say, 5 are solutions. Solutions to this equation. Okay, let's start with maybe x5. It's very simple, just like we did with the expressions here. We're going to plug and simplify. We're just going to substitute the letter here with its value, the given value to check. And we're going to simplify and see what kind of statement do we get. Do we get two equal sides or something else? Based on that, we will decide whether these values are solutions or not. Okay, so we need to plug them. So plug and simplify. So the x here is 5 is given, and say 5 plus 4. And since we're checking, we need this question mark over the equal sign, because we don't know yet. That's what we're trying to find out. So we plug the 5. So this is 5 plus 4. Is it equal to 7? Then you simplify both sides. It's not always this simple. You could have a lot of stuff here, parentheses and numbers and exponents, maybe on the other side as well. So you need to follow the order of operations, just like here. Simplify and see what you get. So 5 plus 4, that's 9. And we have 7. Obviously, 9 is not equal to 7. This is a contradiction. So 9 is not equal to 7. So what do you say about this possible solution, x5? Is there a solution or not to this equation?
No solution.
That's right, it's not a solution because it gave us some false statement here. So we can say 5 is not a solution. So we reject that. We have another number, another possible solution. So the only way to find out again, is to try it or to plug it into this and see if it works. You may figure out that it already works, but let's do that the formal way. So I'm going to take that, plug it into this. So instead of x, we're going to put the 3. I'm going to say 3 plus 4 is equal to 7. Again, for the first, before you get to the last line, you want to put that question mark here because we don't know yet. And once you simplify, you get this and this. And it looks like it works. So this is a true statement. Okay, so what do you say about x3? X is solution. Here it was not. In this case, it is a solution. Okay, so let's see now with another equation, maybe not as simple as this, and try to figure out if some numbers are solutions or not. So this was one example. Okay, let's do another one. Maybe we could take 3x minus 1 plus 2. It is also possible to have some x's here on the other side. Say 2x and plus maybe 3. So we're gonna we're not solving in this. We're not solving today. We're just gonna check a couple of solutions and see if they work. So let's first try maybe x5, then try another one, x4. Again, either one, they could be solutions, that could be not. We don't know yet. So we need to check both of them. All right. Why is this acting up? Okay, so let me rewrite that. Plus whatever this was probably 3. So we're going to check both of these. Check x5 and x4. Start with x5. Okay, so again, it has to go into the equation. Then going to simplify both sides and see if that's a solution or not. So there's 3. Instead of x, I'm going to put 5 minus 1 plus 2. And again, we don't know yet. We need a question mark. 2 times x being 5. All right, so this was a little longer than the previous one, so we're going to follow the order of operations. Start with the left side here. What do you do first? Everybody, where do we start from to simplify this slide? Same thing as Pemdas with operation. Do we start from? Nobody has an idea on how to do this?
Parentheses first.
That's right. I'm gonna do the parentheses. That's 4
Yeah.
and plus 2. Then question mark. Here, of course, what do we do first?
Multiplication. So it's going to be 2 times 5, which is 10 plus 3.
That's right. And back here again, multiplication. That's 12 plus 2. Question mark and 13. Finally, 14 and 13. What do you think of this? What do you conclude now after this?
It's not a solution.
Exactly, not a solution, because it may look close, but it's not a solution. It has to be exactly the same. So this is not an equality. This is an inequality. So let's say 5 is not a solution. Okay, let's try the other given value, x4. Pretty much the exact same steps. Okay, I'm just going to plug the x again into the equation and see what we get. It's going to be 3. 4 minus 1 is 4. And 2 multiply 2x. X again is 4. And plus 3. Okay, the order of operations again. So the parentheses, shouldn't have put the x. We need to substitute it with 4. Let's erase that. Let me try again. Here we go. Okay, again, we substitute the x with the solution, the possible solution, and then see how it works. All right, parentheses first. So each side has its own order. So we're going to do this one first. That's 3 times 3 plus 2 equal sign 8 plus 3. Back to this multiplication before addition. So it's going to be 9 plus 2 over here. Still have that question mark. 8 plus 3, which is 11. Finally, 9 plus 2, that's 11. And 11, as you can see, that checks. No need for that question mark now because this is a true statement. So no need to question it. It's a fact. And that works. For this one here, it did not work. It's not a solution, but this one works. Okay, so this is not a solution. But this one here is a solution, so you can say it checks. So finally, you say x or x4. 4 is a solution. All right, so that's basically how we check equations for solutions. We're going to learn again how to solve all sorts of equations, first degree equations, in a future class in detail. But for today, just starting easy and slow, just doing some checks, basic checks with plugging and simplifying. Okay, everybody, you guys all right? Any questions so far?
No, sir.
No.
Okay. Everybody else, please let me know if you have any questions at any moment. And okay, if you don't have any questions, I'm gonna move on to the next, the last section. I'm gonna talk a little bit about some translations. So the expressions are not always written like this in X's and numbers, you know, not always written like this. Sometimes we have to, when it might be written as a word problem, okay? A word problem, which you need to first translate into an expression and then do whatever we did with it. I believe number 4. All right, so we're going to try to translate some sentences into expressions. First example. So the sum of a number decreased by Okay, this is an algebraic expression, but it's actually not written as an expression yet. So we need to translate it. So to translate an expression, what you want to do is read it a couple of times, understand it, especially focus on the keywords that may mean or but we can replace with some algebraic or math symbols. So obviously here, when you say sum, means you're adding. So the sum of something, a number. That number is not given, okay? Decreased by 3. So the sum of a number, I think we're missing something in this sentence, the sum of a number. And yeah, we need a second part to this sentence. Sum has to be between two things, sum of a number and something. Let's rephrase that. You can say the sum of a number and let's say 5 decreased by 6. Okay, that's a complete expression now. So the sum again means to add a number. So we don't know a number. So this when we need algebra. So algebra basically it means to use letters to refer to the numbers that we don't know or numbers that change in value as we saw earlier. So basically we use this to complete the expression to put together the numbers and letters. So algebra allows us to use letters to refer to the numbers that we don't know or change in value. So a number, we could refer to it as X or Z or Y or any letter. It doesn't really matter what letter you refer to it. So the sum of a number X and 5, obviously 5 is 5. And when we say decrease, what is the operation associated with that? What's the operation of decrease? Everybody? To decrease?
Subtraction.
Subtraction, right? So we have decrease, and the opposite of it is? The opposite of decrease is increase. So decrease, subtraction, and of course here, this number. Pretty much have everything we need. Now we're just going to write the symbols and letters and numbers together into one expression. What would the expression be? Can someone give us the whole expression based on this? So the sum means plus of what? What goes on both sides of the x? Sum of a number that we don't know. We're going to call it x. And 5. And then?
-6.
Exactly. -6. And we could probably simplify this into x minus 1. We're going to talk about simplifying expressions in another class. Okay, so look out for the keywords. Each sentence might have a word that you need to translate correctly. Otherwise, you change the expression or the operation. It won't be the same. Let's do another one. Twice. All right, twice a number increased by seven. All right, it's a pretty simple one. Let the number be, for example, n. Okay, increased, that's a plus. Of course, we have a 7 here. What do we mean by twice? Twice means 2 times. Right? Someone give us, it's already here pretty much. What is the full expression?
2n plus 7.
Exactly. So twice a number means 2n plus 7. That's it. That's the answer to that question. You'll see some of these in the homework just asking you to translate. You will not say simplify unless it says simplify or do something else. You don't have to do anything else. Just change it, translate it, and that's it. Let's see. There's another one. So this time, the quotient of a number and and 4 multiplied or okay, multiplied, that's fine. By 2 or multiply by twice that number. Quotient of a number and 4 multiplied by, yeah, some number by 5, for example. So we have we have a couple of keywords here. I mean, we have that one, of course, multiply is multiply. And what is the operation when you say quotient? What is the operation associated with that? Of course, we can refer to the number as anything, for example, x. When you say the quotient of a number and 4, how do you write that? Or what is the operation associated with quotient? Quotient is basically the result of division. So when you say the quotient of 2 numbers, that means the division of those 2 numbers. or the result of the division of those two numbers. So the quotient of, it's got to be a quotient like this, symbol, a division symbol, and then a couple of numbers here. One of them here is x. We don't know that number, and 4. Okay, and then multiply it by 5. That's pretty much what that expression is. Again, no need to simplify it or do anything. It doesn't. The question will, for now is just about translating. And there are a variety of words that we use for addition, subtraction, and all the operation. Could be subtract from, or difference, or added to, or more than, or more, or less. All these synonyms can mean pretty much the same thing. I believe we have in the book, there should be a list of all those words that you might come across when translating expressions. This could also be, let's say, here's another one, 3 times. Not 3 times, but okay, 3 times maybe the difference. Okay, 3 times the difference of a number and 2 added to add to 5 is twice that number. All right, so there's a long one here. There's a lot going on here in this sentence or word problem. So 3 times the difference of a number and, I don't know why I wrote and twice. So 3 times a number and 2 added to 5 is twice that number. So let's go over this, try to write the keyword, translate the keywords first. So 3 times, of course, means 3 times something, right? Difference. What is the operation associated with difference?
Minus.
A minus. Very good. And a number. How do you refer to that number?
X.
Okay. Very good. And then n2. Gonna need that. Added to. Obviously, that's addition. Is. How do you translate is? The symbol of it. For example, you say, give you an example. If you say the sum of 5 and 1 is 6.
Oh, equal.
An equal sign, that's right. Sum of 1 and 1 is 6. That is equal sign. So that's important here. What kind of statement are we going to have in this? Is it an expression or something else? It has an equal sign, so that would be.
Yeah, it's an expression.
Expression, right?
But you will have an equal sign in it, so that would be. If it has an equal sign,
Solution
it will be an equation, right?
or equation.
That's the difference between expressions and equations. So this is an expression. The left side is an expression by itself. But if we add an equal sign, so that's an equation. Since we have an equal sign here, that means the translation here will be an equation. What else? Twice that number. When you say twice that number, what does that mean? So 2 times that number, referring to what?
2x again?
That's right. That's right. We're referring to that number, so it's going to be an x again. So twice that number, 2x. That number, and less 3.
Minus 3.
Exactly. So this will be less 3. Less, or you may say more 3. Not more than, but less than. Just less 3. More, if you say less than, that would mean the symbol of less than. But if we mean subtraction, just say less something. For example, you have $15 less 3 will be 12. So less itself refers to subtraction. All right, now someone give us the whole thing, the whole equation. Okay, look at everything, or just side by side, since we have 2 sides here. So the equal sign is here. So give us the first part, and then we'll do the second part. So you have an equal sign somewhere here. What's the left side of the equation?
3 minus x.
3 minus 6. But here, he does not say 3 minus 6. He does not say 3 minus a number. It says 3 times the difference. So anybody else want to try? It's going to be 3 times the difference.
So it would be 3 times x minus 2.
X minus 2. But we're missing something here. This looks like 3 times x. If you keep it this way, it means 3 times.
Would it be parentheses?
Exactly. Parentheses is very important here. Are very important. So 3 times the difference. This is the difference. Again, if you don't put parentheses, it would look like 3 times a number minus 2. That's not what it says here. 3 times a number minus 2. But 3 times something. That something is this. The difference. Difference means subtraction. What else? Second part. I mean the other part here is added to 2.
Oh,
Okay. Finally is and
5. Well, I'm not too sure about the second part. I just with the comments messed me up.
so twice. So the is this one. The is the equal sign. You just need to translate twice that number plus 3.
Okay, so it's times 2. So I think it's x times 2
Mhm.
minus 3.
Or 2x, right? 2x minus 3.
Okay, I say 2x from now on.
Okay, and that's pretty much it. So this again is an equation because it has an equal sign. These are just expressions. There is no equal sign. The question here is just to translate. Maybe the question will ask you again to check for a solution or something. Maybe later on when we do the solving of equations, he may ask you to solve or check for a solution. So again, this one is this. And twice is this part. 3 times. So the difference basically is this. And this times is invisible here. Of course, 3. 3 times, that times is here, added 2. And that's basically how you use algebra. So algebra again is numbers and letters. You use that to apply it to real world problems and solve them. So we translate something into math language. This is math language here before you can solve it. And I believe that's pretty much it for today's lesson. In the future, we're going to learn more about each one of these topics in detail, including equations, simplifying expressions, and going to be using variables throughout this class pretty much. It's an algebra, so algebra again means letters and numbers. And sometimes, all the problems are not always written in math problems. We have to translate them into math problems and solve them. They're always written, or written in word format. If I buy this and I use this and I have twice that amount left of some other stuff. So these words that come to your mind and you try to solve a problem, if you translate them into a word problem like this, then once you translate them, the solving of the equation is not that bad. We know how to solve them. So the important part is to get the translation right. If you don't get the translation right, there is a very small chance, so there's no chance of you getting the right answer.